last example under this. Okay, so this time we have a homeowner, sorry, wants to install a deck around her swimming pool. The swimming pool is a rectangle and measures 25 feet by 32 feet. The deck is to have the same width all the way around the pool. What should the width of the deck be if she has 310 square feet of decking material? Okay, so let's look at our given. Obviously, what we want to do here is we know that a few different things. We know that the deck material that we have has to equal 310 square feet. We also know that we have a rectangular swimming pool, and I'll just bring up my shape. Here's my swimming pool, and I have a deck that goes around it. Okay, and it's supposed to be the same distance all the way around. So that right now isn't, so I will move it a tiny bit. So that looks pretty good. So what we have in here is we have our pool. We know, we're also told, excuse me, we're also told that we have, it's 25 feet, and we're told also 32 feet. So we're told those measurements. Now what we want to look at is we want to look at what is required of us. Obviously, what's required of us is we want to find the width of the deck. Well, actually, I'll make that a little bit larger for you so it's easier for you to see. So we want the width of the deck. So in other words, the distance from the pool to the deck edge. Okay, so that's what we're after. So let's look at our analysis here. And we're going to actually take our shape to do this analysis. So we're going to take this, and hopefully I can just kind of clone it a bit and bring it down here. So I'm bringing it down here, and what we know is this distance that's going all the way around, and I'm going to actually just kind of put it here. We know that these distances everywhere are the same. Okay, so they're all equal to each other. Everywhere is equal. And what they want us to find is this in here, and I'll just do it in highlighted. So they just want this area in here. Okay, that's what we're interested in. That's our deck. Okay, so the first thing I'm going to do is, because I don't know what that width is, I'm going to let it be with my let statement. So I'm going to let the distance from the pool to the deck edge be X. So if that's the case, what I end up with in my question, and I'm just going to take actually an X so I can put it everywhere that I need one. So we have an X, and we have one here, and I'm going to clone it. I have another one here. And the reason I'm putting it in all places is it might be easier for us to figure out what we need to do to find that yellow area. And I'm almost finished cloning X's everywhere. So there's X's everywhere. We also know, again, that, oops, that's not what I wanted. So we know that the distance in here also is our X value all the way around. So one of the things that we could do is we actually could calculate each one of these yellow strips. Okay, you can see that we have 4 that are identical, 1, 2, 3, and 4. So we could calculate those, and then what we could do is we could calculate these 2 which are the same, and then the N2s that are the same. So we actually could take our area formula and use it 3 times in order to find what we want. Okay, so what I'm going to do is we're going to look at, first of all, our little squares, in our solution, and they are x by x, and we have 4 of them. So the area of that would be area would equal, oops, sorry, area, capital A, would equal length times width. And we know in this case that would, and we need 4 of them. So let's put a 4 actually in front here, a 4. So we know that we have 4 times, and x times an x would be x squared, obviously. So that will be on our next line. And I'll just make that out a little bit further. So we end up that being 4x squared. Okay, so what we've just found now is these ends. So we have 4 of them. So those are taken care of. Okay, so now let's look at the next set of areas that we want to look at, and we'll call them area 2. So this is area 2. They're identical. We know that the length of them, of these, are 32 feet, and we know the width is 2. So we need 2 of those, so we're going to take the area 2 times the area of the second item is also going to be length times width, and we know that's then going to equal 2 times the 32 times x, which would be 64x. And lastly, we'll do our ends, and so our ends are here, so we're going to call them 3 and 3. So we have 2 of them also, so its area is going to be 2, the area of the third shape, and it equals also length times width, which would be equal to 2 times, in this case, the 25 times x. And when we do that, we end up with it equaling 50x. Okay, so really all we should have to do is we should just be able to add these together and then calculate. So let's go and do that. So when we do that, we end up having the total area. I'm just going to put this out of the way since it's in our way. Area total, and so we'll use a subscript T for that, is going to equal these items. And I think what I'll do is, since I have the ability to pull it out, I will. 4 of those, 2 of those, and 3 of these. And we're going to put them all together, and we're going to add them as soon as it stays where I want it to go. Here we go, and we are going to add those areas together. Now when we do that, we're just going to substitute this information in. I'm just going to move mine up a little bit so that I have enough room to keep working, and this is what we end up with. It's going to equal the 4x squared plus the 64x plus the 50x, and then we would gather our like terms, and we'd end up with 4x squared plus 100 and, let's see, sorry, just adding this in my head, so sometimes doesn't work very good, 114x. And the other piece of information we have is, if we go back to what we have up here, we want the deck to have this amount of material. So that's what we need to also bring down. So if I bring that down, because that was another piece of information that we needed in this question, I know that this has to equal this, because that's what's given to us. So when that is put together, remember what we have to do is we have to solve for, and we have to have a 0 on this side. So that's the next step that we will do. And so we're going to have 0, move that out of the way. 0 equals 4x squared plus 114x minus 310. Now, I don't know if you remember that previous example that we did, we were able to factor something out. And in this case, we can too. Actually, 4 will go into each one of these. So I'm going to divide everything. Oh, no, sorry, 4 won't. By 2. 2 goes into everything. And if I do that, that just makes my numbers for the quadratic formula a little bit easier to work with. So when I divide by 2, I end up with 2x squared plus 57x, oops, didn't want to go where I wanted, plus 57x and minus 155. Now, using our quadratic formula, we're going to substitute that information into it. And so I'm just going to pause, and not that it seemed like pausing to you. And let's put our numbers in here now. So we have equals, switching to my writing utensil, get up there. So we have negative 57 plus or minus the square root of 57 squared minus 4 times 2 times the negative 155, and all of that is over 2 times 2. And again, when we actually work those through, we end up that x equals negative 57 plus or minus 67 all over 4. And again, if I have negative 57 plus 67, I know that is approximately divided by 4 is 2.45, sorry, 2.5. And if I do negative 57 minus 67 divided by 4, I end up with negative 31. Now, obviously, negative 31 is that inadmissible, so we can't use that one. Or you could say here, not possible. That's acceptable too. Sorry, my writing pen doesn't want possible, and that's acceptable. And finally, we need a therefore statement, and for somewhere, there we go. So therefore, she should make the deck 2.5 feet in width. Okay, so there we go. That's the last example, as I said. Some more lovely questions for you to work on. I will also post what's required for you on the website. So have fun.